Hello viewers, in today's class we are going to discuss yet another important application of Lagrange's mean value theorem, right? So here we'll consider one inequality which will be proved by using the Lagrange's mean value theorem, right? So here using the Lagrange's mean value theorem, we have to prove that 1 plus ex square is greater than e raised to minus x square for all x greater than 0, right? So here e is the exponential number, right? So now let us prove this inequality by using the mean value theorem, right? So what we will do, let us first suppose an appropriate function here, right? So here, in order to prove this inequality, what we will do, we'll take an appropriate function to which we'll apply the Lagrange's mean value theorem, right? So we'll take fx is equal to log of 1 plus ex square minus x square for all x greater than 0, right? So here we'll assume this function, right? And let us apply the Lagrange's mean value theorem to this function, and let us see whether the conditions of Lagrange's mean value theorem are satisfied or not, right? So here since we have x greater than 0, so let us consider the interval that is 0 comma x, right? So let us take the Lagrange's mean value theorem in general form. Suppose we have a function, say y is equal to f of x defined in some domain, and let us take the domain as D, and let us define an interval a comma b which is a subset of this domain D, right? Now if this function y is equal to f of x is continuous in the interval a comma b, and if this function f of x is differentiable in the open interval a comma b, then mean value theorem says that there exists a point x is equal to c belonging to this interval a comma b, such that f prime of c, that is the derivative of f of x at the point x is equal to c, is equal to f of b minus f of a divided by b minus a, right? So this is the statement of Lagrange's mean value theorem, right? So here we have the function log of 1 plus ex square minus x square, right? And see, this function f of x is a combination of logarithmic function and the quadratic function, or we can say the polynomial function, right? And we know that the log function is continuous in the uh, domain D in which this log function is defined. So log function is continuous, and this polynomial function is also continuous, right? So we have the combination of two continuous functions for all x greater than 0, right? So here f of x is defined as log of 1 plus ex square plus minus x square, right? So this is continuous, and minus x square is a polynomial function, so this is also continuous, right? So we have the combination of two continuous functions, hence we can claim that f of x is a continuous function in the interval 0 comma x, right? Okay, now let us take the second condition. So here the function f of x has the derivative. Let us find out the derivative f prime of x. So this is d by dx of log of 1 plus ex square minus the derivative of x square, right? So now the derivative of log 1 plus ex square is 1 over 1 plus ex square, and by chain rule the derivative of 1 plus ex square is 2ex, and here we have 2x, right? So now f prime of x is equal to 2ex divided by 1 plus ex square minus 2x, right? And we can easily see that this function and this function is valid for all x greater than 0, right? So we can safely claim that the function f of x is derivable or differentiable in the interval 0 comma x, right? So the two conditions of mean value theorem are here satisfied by this function, right? So there must exist some point x is equal to c between a and b, that is c is greater than a and less than b, such that f prime of c must be equal to f of b. B is x, so we have f of x, and here we have f of 0, and divided by x minus 0, right? So now we have f prime of c is equal to f of x minus f of 0 divided by x minus 0, where a is x, a is 0, and b is x, right? So here f prime of c can be obtained by taking x is equal to c in this expression, right? So here we can now write 2ec divided by 1 plus e c square, right? And minus 2c, right? And here f of x is the log of 1 plus ex square minus x square, and f of 0, when we take x is equal to 0 here, then we see that a log of 1 plus 0, here we'll have 0, and then we have 0 square, so we have log of 1 that is equal to 0. So here we have 0 and we can neglect this 0, right? So here we have simply x, right? So now we have this expression. So now here this point that is c, this point c is greater than 0, but it is less than x, right? So c lies between 0 and x. Now let us first consider this term, right? See, here we have 2 times of ec divided by 1 plus ec square. Now e is the exponential number, which is a positive quantity. C is also a positive quantity, and 1 plus ec square is also a positive quantity, right? So overall this quantity is greater than 0, right? Because c is greater than 0, right? Now let us subtract 2c both sides, right? So we have now this inequality, so we'll subtract 2c on both sides. So we'll get 2 times ec divided by 1 plus ec square minus 2c is greater than minus 2c, right? So now we have this inequality, right? Okay. So now what we will do, we'll substitute the value of 2ec divided by 1 plus ec square minus 2c as this expression, right? So now we have a log of 1 plus ex square minus x square divided by x minus 2c. Here we'll have greater than minus 2c, right? So now we have the third inequality here, right? Okay, now let us consider this inequality, right? So we have obtained this inequality number 3. Now let us develop another inequality by taking this one. So here we have c is greater than 0, but it is less than x, right? So now let us multiply throughout by 2, right? So what we will get, here we'll get 0, here we'll have 2c, and here we'll have 2x, right? So now we have 2c greater than 0 but less than 2x, and let us now take this inequality, right? So we have 2c greater than 2x, right? Now let us multiply both sides by -1. So what we will get here, we'll have minus 2c, and the direction of the inequality get reversed here, so we'll have minus 2x, right? So now we have inequality number 4, right? Now if we merge these two inequalities, right, see here this term is greater than minus 2c, and minus 2c itself is greater than minus 2x, right? So if we merge these two inequalities, what we will get, we'll get log of 1 plus ex square minus x square divided by x is greater than minus 2c, and minus 2c is greater than minus 2x, right? So this is our inequality number 5. So now we'll take this inequality number 5, right? And see, here we'll take these two expressions, right? So now we can write log of 1 plus ex square minus x square divided by x is greater than minus 2x, right? Okay, so now see here in the denominator we have x, and we have already assumed that x is greater than 0, right? So we can now easily get rid of this x by multiplying both sides by x, right? So we'll have now log of 1 plus ex square minus x square is greater than minus 2x square, right? Okay, so now we can take this negative x square to the right hand side, so we'll get log of 1 plus ex square is greater than minus 2x square plus x square, that is equal to minus x square, right? So now we have a log of 1 plus ex square is greater than minus x square, right? So now this is a very important result, right? So log of 1 plus ex square is greater than minus x square, and remember here the base of the logarithm is the exponential number e, right? So now to arrive at this result, see what we will do here, we'll take the exponential power of both sides, right? Or we can say in other words that we can raise both these terms to the power of the exponential number e, right? So we can now write e raised to log of 1 plus ex square is greater than e raised to minus x square, right? So what we have done here, we have taken the power of both sides to the exponential number, right? So now here see, we know an important result from calculus that if we have e raised to log of a, then we can write it as a, right? So here our a is 1 plus ex square, right? So now we can write 1 plus ex square is greater than e raised to minus x square, right? And this is our desired inequality, right? So we have 1 plus ex square is greater than e raised to minus x square for all x greater than 0, right? So viewers, this is how, by making use of the Lagrange's mean value theorem, we can derive these type of important inequalities.